Welcome back to another episode of Bitfinex Talks. I'm your host, Ricardo Martinez. Today, I'm here with Luke Parker, who is the lead developer for Sarai, which is a decentralized exchange. Luke, thank you for coming on the show. I'm happy to have you here. How are you today?
Doing well and happy to be on the show. Thanks for having me.
Can you explain what Sarai is, please?
Yeah, sure. It's a decentralized exchange focusing on servicing Bitcoin, Ethereum, and Monero, with that latter one being what's getting us most of our attention.
Is Sarai live yet, or is it still kind of like a project that's like in the works? Like, have you launched like a beta version or anything yet?
No, it's still very much in the works. We're hoping to have a testnet within a few weeks. So I have to go into a bit of backstory to explain this. Sarai is written from the ground up. We're not just a fork of anything. So because we're not a fork of anything, we're not a fork of any existing cross-chain exchange. We're not a fork of the Uniswap smart contracts. We're not a fork of whatever atomic swap service people have used for a while. One of the things we did, being completely from the ground up, is we actually built our own Monero library and integration. Which was definitely a lot of work because we didn't just grab the Monero C++ code and use it. No, I actually re-implemented the Monero protocol itself in Rust. So while Sarai is a few weeks away from hitting testnet, there's actually been a few other parties interested in our Monero library because as a Rust library, it has a lot of safety features. And then since it was designed and built over the last year, and then not the last 8 years, like Monero has been, it's gotten very favorable feedback on its ergonomic usability as integrating. So for the next couple of weeks, we're actually focusing on making sure our Monero library is quality, adjusting the timeline there, just because we have a few other people who are wanting to use it already. So while Sarai is hopefully just a few weeks from testnet, right now the focus is elsewhere. So I'm not actually sure we'll be at testnet in a few weeks.
Okay, wow. That sounds like it's quite an achievement. That does sound like it was a lot of additional work. I wanted to get into how Sarai works. It's like its own network. It's a DAO. Like how exactly are you achieving the decentralized exchange part?
So Sarai is its own network. We're our own layer one. We're not just like a set of Ethereum smart contracts, which would be incapable of doing something like this. What Sarai does is we have nodes sign up to the network and put up some of the Sarai token as collateral. And by doing so, they're entered into a multisig. And as part of being in this multisig, they're allowed to participate in securing coins from other networks, such as Bitcoin, such as Monero, such as Ether. And then the actual swap experience, reporting, flow, coordination, that all happens via our own L1, which is built off of the Substrate framework. I'm not sure if you've heard about that. Just as Cosmos is a blockchain framework, Substrate's another one.
Thank you for that explanation. Can you give a brief overview of how privacy in Monero works currently?
Sure thing. So in Monero, currently, there's a few different technologies at play. There's referring to the on-chain privacy. You know, you publish a transaction. This is what it looks like once it's confirmed on the blockchain. We use a technology called bulletproofs to hide the amount, or technically it's now bulletproofs plus, which is a slightly improved version. So what bulletproofs does is we just use it to hide the amount. And that means if you go on the Monero blockchain, you can't see the amount any transaction is spending at any given moment unless it's the miner reward, because that's calculated by everyone on the network. As for there's a couple other aspects to on-chain privacy. There's sender privacy and receiver privacy. Sender privacy means when I send a transaction, no one knows I was the one who sent it. Receiver privacy means when you receive a transaction, no one knows you were the person to receive it. We handle receiver privacy via stealth addresses. Stealth addresses, just when you receive funds to a stealth address, it looks completely indistinguishable from any other output on the blockchain. And that's why if you go to a Monero Explorer and type in your address, you're not going to get any results. No one can just take your address and look up what outputs you received. As for sender privacy, currently Monero uses something called ring signatures. Ring signatures are you take your output and then you select 15 other outputs from the blockchain. So you end up with 16 outputs, one that's yours, 15 randomly selected ones, and you produce a signature, and your signature says, one of these outputs is mine, but I'm not going to tell you which. You can't tell them apart. So that means, yes, you have an output. Yes, it's the one being spent. But as for privacy, all that can be known as it's one of 16. And this is not insignificant. It's hiding the center to 1 out of 16. If you were to randomly guess at that, it would be 8% odds. 7%. It would be roughly 7% odds. The main issues with ring signatures and privacy come down to when you randomly select outputs, you might randomly select an output that someone else knows is theirs. You know, if one of the outputs you select might belong to a major exchange, and if you select an output that belongs to a major exchange, well, they might at some point publish what outputs they've interacted with for legal requirements, reporting requirements, or just as some effort of transparency. And now anyone can go and say, hey, we know this output belonged to this exchange, therefore it could not have been your output. Therefore, you didn't actually select 16 possible outputs, you selected 15 because we were able to deduce that this one could not have been it. And that's where ring signatures kind of fall apart, though they are still great and they do protect a lot of the sender's privacy. We also have a couple other mechanisms for privacy. That's just the on-chain. We also do network privacy. We encourage users to use Tor so people can't tell where their transactions are coming from. And then even if you're not using Tor, we have Dandelion++, which hides which node is publishing the transaction in the first place. And then with our wallets, we also have a lot of effort against leaking metadata, such as what wallet you're using, by ensuring wallets all follow the same practices, craft transactions the same way, and appear identical on chain. So also you should not be able to tell what wallet someone is using when they send a transaction.
The reason I asked you about how it currently works is because Monero has like a proposed roadmap where there's an upgrade that's been talked about, which I don't know if it's been decided that it's 100% going into it, but it's called Seraphis. So I wanted to ask you if you could talk about Seraphis really quick and briefly without getting too technical.
So Seraphis is actually a new privacy protocol. So when Monero launched, it didn't have quote unquote ring CT. Ring CT is referring to using ring signatures to hide the sender, and also confidential transactions. That's the CT part, which actually is a proposal dating all the way back to Bitcoin. Confidential transactions just hides the amount. So Monero, when it launched, it didn't hide the amounts at all. It just had ring signatures. Then we evolved it to ring CT, which means we had ring signatures hiding the center and confidential transactions hiding the amount. And now we're proposing Seraphis. Seraphis is just as good from a privacy standpoint as ring CT, but its major evolution is how it breaks down the privacy protocol. Instead of just saying, yep, we took all these technologies and just squished them together into a big ball. Seraphis is like, nope, we have this technology here, then this one, then this one, then this one. So it's just very formal about how all of the technologies come together and how they interact. And with this clear delineation, not only comes a bunch of feature improvements, the ability to perform better academic review and say, yep, this proof only has to do this. We can confirm it does this exactly as needed. We don't have to worry about how it interacts with another proof. But with all of this, it also gives us the opportunity to use new technique for sender privacy. Under Seraphis, we still use, under the prior and arguably currently proposed plans, Seraphis replaces the ring signature with what's known as a one out of many proof. So our current ring signature says, hey, I have these 16 outputs, one of them is mine, and I'm using it for this transaction. With a one out of many proof, it says, hey, there's these outputs, one of them exists. And it doesn't say anything else. It doesn't say you're the owner of it. It doesn't say you're spending it. It just says, yep, this is an output that exists. This output, which looks completely different from anything else out there, is actually one of these outputs, just modified slightly to hide it. And that's known as a one out of many proof. And because Seraphis breaks down our proving flow, we're allowed to use this different proof, which does less, but is also much more efficient at proving it's one out of some set of outputs. So with Seraphis, we were actually discussing moving to 128 outputs, not just 16.
Well, thank you again for the excellent explanation. So the big news that you announced recently, I think it was at MoneroCon, like
Yes.
last week or the 2 weeks ago, maybe.
Mhm.
You announced full membership proofs, and
Mhm.
full membership proofs are like a radical improvement as well for privacy, if I'm not mistaken. Could you please explain what full membership proofs are and how they're different than Seraphis, I guess, or if they require Seraphis to be implemented in order to implement full membership proofs? Like, could you explain it for us?
Right. So full chain membership proofs, instead of saying, oh, here's 16 outputs and my output is one of them, they're saying here's 128 outputs and my output is one of them. What full chain membership proofs do says, here's the entire blockchain, my output is one of them. So it's still just saying my output is one of these outputs, but now it's at a scale of the entire blockchain. Technically, you could use ring signatures to do that. It just might take a couple weeks to verify. Technically, you could use one out of many proofs to do that. It just might take some amount of days to verify. But with the proof currently being discussed, it's actually based off an academic work known as curve trees. No, we're looking at less than a second to verify. Ideally, we're going to get it down to roughly 15 milliseconds. Though right now it's a bit higher because it's still a work in progress. So what I announced, is an implementation of full chain membership proofs based off an academic work known as curve trees, which would allow us to achieve a privacy set not just of 16, not just of 128, yet up to 777 million outputs. And if we ever do go past 777 million, we just double the proof time, and now it's up to many, many, many more outputs. So it's not like some inevitable end of Monero. It's not like, oh, we hit 777 million, that's it, shut the chain down. It's just the current time is for 777 million. And if we ever did get that many outputs, the proving and verification time would go up slightly.
That sounds incredible. If all these proposed improvements like are implemented in Monero, what would change for me as like an end user that just wants to send and receive payments and have a little bit of privacy?
For the end-to-end user, it's not going to change much. There's a lot of privacy discussions. I don't know if you've ever personally tried out Bitcoin in privacy solutions like I think Sparrow is the recommended one nowadays. And with Sparrow, it's like you receive funds and it marks them as dirty. And then it moves them through the Sarai whirlpool. And it says how many times they've been coin joined, mixed with other people's funds. And then it gives you the output. And it's like, yep, these are the funds which have been coin joined. You can use them if you want. But the other thing Sparrow does is it doesn't just say your funds are private at the end. It says like, this is the amount of times it's been mixed. Because the more times you mix it, the more private they get. And then the other thing is it actually doesn't say you have 10 Bitcoin. It says you have 0.5 Bitcoin that's been mixed twice. You have 0.1 Bitcoin that's been mixed 5 times. You have so on and so on. Sorry. The significance of that when we're discussing wallets like Sparrow is Sparrow, when you do finally spend your Bitcoin, when you finally get your cup of coffee, when you finally order whatever off of Amazon, Sparrow wants you to think about which outputs you're spending. Because if you spend an output that's only been mixed once rather than been mixed 5 times, that's going to have less privacy, so on and so on. So it becomes this very complicated game where you have to like keep an internal notebook in your head of where these funds came from, how much privacy you even need for this transaction, how many times it's been mixed. You have to consider if you want to be truly private. Oh, but am I being targeted? Is it possible my ISP is trying to figure out what transactions are mine? And it's this very complicated internal thought process that you might have to spend a couple minutes on every time you want to spend Bitcoin if you're truly in an OPSEC critical environment, if you truly don't want anyone to figure out where your transaction is coming from. And that's really annoying and stressful. And while most people who use Bitcoin privacy, they'll be fine just using Bitcoin, or they'll be fine going through one mix and calling it a day, or they'll be fine running the mixing service in the background, maybe getting up to like 5 mixes, and they'll just spend from there. They don't have to worry about that. If you truly want to be private using Bitcoin, it's a very involved and difficult process that I can't recommend to anyone. And the goal of Monero as a privacy coin is to solve that. You don't have to worry about that. You just do it. You just have a wallet. It shows you your balance. You spend coins and you move on. But unfortunately, under rings, we kind of have this problem pop back up. If you truly need to be concerned about your operational security, now when you spend an output, you're selecting 16 random outputs. Or sorry, 15 random outputs to get a total of 16 outputs, which may be yours. And it's not really about what outputs you select, though that can be part of it. It's more about the patterns that form with your actual output. And this is most frequently brought up with the EAE attack. The EAE attack is where you have an exchange send you funds, so your transaction is here, and then you send the funds to another exchange. So it goes exchange, you, the other exchange. Those exchanges, if they want to try to de-anonymize you, they can say, yep, I sent Luke funds here, and Luke sent those funds on here. And technically, the exchanges don't know that the funds from exchange A went to exchange B, because I did use a ring signature, and this was one possible output, but there was also 15 others all the way up. But practically, they can say, well, these have the same amount. And because they have the same amount, the same value, probably same person. You know, this exchange sent 10 Monero, and then this transaction, which may or may not be spending from this exchange, sent 9.9 Monero to this exchange. So when people around you collude, when they work together to de-anonymize you, and this mainly happens in targeted surveillance situations, ring signatures can kind of be broken down. And you can just send to yourself in the meantime. You know, you don't take 10 Monero and immediately send it to the other exchange. You go 10 Monero from exchange number 1, yourself again, and then 9.8 Monero to this other exchange. And now we get to discuss the EABE attack, where it's still 2 exchanges on the end. It's now, instead of just A, there's also a B in the middle. And you can kind of continue the statistical analysis, and it's not guaranteed. At any point, yeah, that could be you, that could not be you. If we just had, you know, just 3 members in the ring signature, there's no guarantee to it, because you can't truly determine it. But the issue is that some patterns can be determined, especially when the people you interact with are trying to track you down. So what full chain membership proofs does is it just eliminates that. While if you have full chain membership proofs, it's not selecting, you know, 1 out of 16 outputs. It's not selecting 1 out of 128 outputs. It's selecting from any single location on the chain. And because of that, if you try to perform targeted surveillance against a transaction, you have to consider I think right now, if I pull it up, we have roughly 70, 80, and 90 million outputs on the chain. I believe it is close to 100 million outputs on the chain. And that means you're not just trying to eliminate from a group of 16, you're not trying to eliminate from a group of 128, you're trying to process 100 million outputs of data and say, can we eliminate these? And when the transaction itself doesn't give up really any info, it becomes an insurmountable task. So for the day-to-day user, it doesn't really mean much. But from people who are truly concerned about their operational security and need the utmost privacy, this eliminates any considerations necessary there. And then for us as developers, it also simplifies our life a lot, because now we no longer have to worry about selecting those other 15 outputs, because that has this whole algorithm involved. It's known as a decoy selection algorithm, and that's its own ordeal. So for developers, it does simplify our life a lot.
Are there any like trade-offs or possible drawbacks to making these changes?
Sure. So unfortunately, if we're doing these full chain membership proofs, it does increase the transaction size a bit, and it does increase the time to handle it. I believe right now with Seraphis, we were looking at a 1 out of many proof, and that would have gotten us to 128 ring members. I believe I ran a benchmark on that just to see how fast it ran, and it was roughly 7 milliseconds, which is 7,000ths of a second. To us, that's meaningless. But to a blockchain that wants to handle, hundreds of transactions every few minutes, yeah, suddenly that starts that up, because now we're talking about, entire seconds being spent on it. So I believe what we were currently discussing for Seraphis was 7 milliseconds, and I think ideally we get full chain membership proofs down to roughly 15 milliseconds. which means it's going to be twice as slow to verify. And then not only are we looking at being twice as slow to verify, but the transaction size is going to go up a bit. I believe, sorry, I'm trying to remember off the top of my head the current transaction sizes. I believe currently we're spending roughly 600 bytes on our current 16 long Greeks. I believe we're spending roughly 600 bytes in input on those proofs. I don't know how that was planned to change with Seraphis, yet under my work, it goes all the way up to 2 kilobytes. So for the inputs are roughly 4 times larger. And in my initial presentation, I actually misquoted it. I thought it was going to be 4 kilobytes, not 2 kilobytes. And I got a lot of pushback on that, and I understand why. But thankfully, I misremembered, and I just threw an extra ×2 in there. So it is a bit smaller than I initially said, but it's still looking to be about 4 times larger for the inputs. And that's been discussed and will continue to be discussed. But in my opinion, I don't believe Monero should ever become what Bitcoin is. We really do have to say, Monero, you use it, you don't have to worry about it. We're here to build the best service for anyone. It doesn't matter who wants to be private. And as part of that, while Monero's privacy is enough now, under targeted surveillance, there can be questions and concerns, which is why I believe even if we are discussing 4 times larger, it's a step we have to make. And I do believe the Monero developer community agrees with that.
Thank you again for such detailed responses all throughout this whole podcast. You have a gift for making complex ideas easily digestible. We're about out of time, but I wanted to ask you, is there anything that I didn't ask you that you feel is important for people to know about full membership proofs or Seraphis or Sarai or anything else that you're working on?
No, I can't really think of anything off the top of my head. Full chain membership proofs coming to Monero hopefully soon. Sarai, decentralized exchange. If you want to move between Bitcoin, Ether, and Monero, look us up.
Awesome.
Yeah.
One question about Sarai before we go. When you say Ether, are you also talking about ERC20 tokens or just Ether?
We are looking at DAI, the stable coin. So if users want to provide liquidity in US dollar terms, that's an option to them. But for ERC20s themselves, we're mainly looking at aggregating with Uniswap. Just because Uniswap is always going to have more liquidity than whatever we attempt to do. And not obviously just Uniswap, but whatever on-chain exchange already has liquidity for those tokens. The main emphasis is on being able to go from Ether to Monero, not necessarily, whatever ERC20 to Monero, because you can always just do ERC20 to Ether to Monero and get the most liquidity that way.
Okay, cool. Thank you for that explanation. It was a pleasure having you on the show, man. I really appreciate it. Thank you for taking time out of your day to explain all this stuff about Monero to us.
Yeah, no, happy to. Thanks for having me on for the opportunity.